I can't wait till I get you on the floor, good looking. Hey, going hot so hot, just like an oven.
And we're going to be doing some exothermic reactions today. Isn't that cool?
That's gnarly.
Yeah, it's pretty awesome. Alright, so this is an exothermic reaction we're going to be doing is we're going to be putting steel wool inside vinegar, and that releases some hydrogen gas, and it just has some steel left over and vinegar. So what I'm going to do is I'm going to dip it in. Whoa! Is that awesome? I'm going to let it soak for a minute, and when it comes out and it's exposed to the air, it's going to give off some heat, and I'm going to record it with this temperature gun. Is that cool? Pretty awesome. Yeah. Alright, let it soak. I'm going to take it out, expose it to the air, record the temperature. It's at 22 degrees now, rising to 24, 26. It's at 30 now. Alright, it's at 32 degrees, and it's still rising. So that's, you just get the general gist of it. It has steel wool and vinegar, and the temperature is going up. That's an exothermic reaction because heat is being released, not being taken in. That's an endothermic. So we're going to write the equation on the board. Fe plus,
Well, that's acetic acid.
yeah, which is one of the main ingredients in vinegar.
And it goes to, so the products are Fe, parentheses, oh, it's not true. And the Fe is iron from the steel wool.
Yep. As you can see, this steel wool has oxidized not only from the heat, but from the vinegar that it was dipped in. Alright, so the temperature of them right now is 0 degrees.
Typical.
Yeah. We're going to make a 28 gram block.
And the temperature of the water is
16 degrees Celsius. So we will be writing two reactions on this one.
This is endothermic.
Yeah, the endothermic reaction of the ice and the endothermic reaction of the water. Isn't that pretty cool?
Yeah, it's awesome.
It's pretty awesome.
This is Mir, also known as Ken Master. When you add a cube of ice to a glass of water, what happens? The water becomes cooler. How does this happen? The ice absorbs heat from the water and in the process melts.
Did you know that the water is also absorbing heat from the ice, even though it's cold, it's still heat. And the water temperature right now is 9.2 degrees.
Correct.
And that's after the ice and the water have interchanged.
Yup.
So-
And the ice has melted.
Yes. So
And Q stands for heat produced, S stands for specific heat capacity, M stands for mass, and the delta T is
The change in temperature.
change in temperature.
H initial minus H final. That's the change in temperature.
So the delta T for water came out to be 6.9.
Is
The
that correct?
mass is 150 grams of water.
Which is also 150 milliliters, but since it's the metric system, they're the same.
And the specific heat capacity of water is 4.184. And when you multiply these together,
You get the heat of the reaction, in
which
joules.
is 4.33 kilojoules.
Yeah,
So that's
that's
heat absorbed
for the
for the water.
yeah for the water. All right, now we're gonna do the heat reaction for the ice.
The delta T, or change in temperature, for the ice is negative 8.7. The mass is 28 grams. and specific heat capacity is 2.18. And when all of these are multiplied, you get a total heat of negative 531 joules.
That's how much heat the ice absorbs.
Have you ever been stuck out in the wilderness but nothing but a 9-volt battery and some
Yeah.
steel wool?
Hell
This is a great way you can start a fire if you're ever cold.
I'm cold.
Yeah. Put the battery up to the steel wool. This will then short circuit it and cause the steel wool to heat up and spark.
Now that is a blazing fire.
Yes. This is David Flynn.
Guys,
I'm going to educate this kid right now. So, what do you think an endothermic reaction is, David?
I don't know.
That's okay, David. Don't. It's okay. What's the next exothermic reaction?
I don't know.
It's alright, man. Do you know what Q equals SM delta T stands for?
No.
Alright, let me teach you. Q equals heat,
Okay.
S equals specific heat capacity,
Okay.
M equals mass, and the delta T equals temperature change. And that gives you the total heat produced.
Thank you, Amer.
You're welcome, dude. My name's John, and I'm going to educate these kids on some endo and exothermic reactions. Do you kids know what an endothermic reaction is?
It has to do with, bro, probably has to do with some wall ball, hitting the ball on the outside or something.
No, dude.
Reactor on the outside. Yeah.
Track.
Bro, something on the outside of the wall.
Running.
No, do you know what exothermic reactions are?
Ectothermic's probably on the inside of the crease.
Probably
Crease
on the
man,
outside of the
little
running.
give and go action, little dip and dunk,
8th lane.
wine and grind with a cross stick, maybe a little D-midi, either or.
Get a D1's calling.
Oh yeah.
Yeah.
Oh, yeah, every day. Alright, so endothermic reaction, heat is taken in. An exothermic reaction, heat is given off.
Yeah.
What's up, bro?
Take it in, yes.
Yeah, take it in. Oh yeah.
Andelman.
Calm down. It's all about heat.
It's all about heat. Yeah, bro.
Heat
Just
of the
moving
shot.
the ball on the
Just think
outside.
heat of the shot.
Yeah, bro.
Deep breath. You ready?
All right, bro.
Today I'm gonna educate Jared on some chemistry and some exothermic endothermic reactions. Jared, what do you think of when I say endothermic reaction?
Reactions in chemistry.
Alright, what do you think of when I say exothermic reactions?
See, when you say exo, I think of ants, because or bees, exoskeletons. So on the outside of reactions in chemistry.
Yeah, you're right. It is on the outside. Exothermic means heat is being released, while endothermic means heat is being absorbed. Like, when you burn something, it's called a combustion reaction.
Oh yeah?
Yeah, it's called a combustion reaction, and what happens is it releases heat. What are your thoughts on that?
Interesting. I should join your class next year. I would like to learn more.
Yeah.
No script, no lines. Off top, baby.
This is real life, the only one we get to live. I remember being broken, thinking something's